For video 4 of quadratic equations, we're going to take some time and work with our graphing calculator to figure out how we can use it to check our work. Keep in mind that using the graphing calculator will only give you approximations of your answers, whereas what we were looking at in previous examples in previous videos were exact. So we're going to go ahead and revisit one of our problems from the last video. 5x squared plus 4x is equal to 3. And in this situation, when you have terms on both sides of the equation, we're going to go ahead and use our intersect function on our calculator. As a refresher, in order to use your intersect function, we're going to go into the y equals screen, and we're going to start typing in what we see on the left side of the equation. So in that case, we had 5x squared plus 4x. And then on the right side of the equation, that will be written on another line. So the right-hand side just had 3. From here, perhaps you had been playing around with your window for previous problems or something like that. It might be a good idea in order to reset it. So I'm going to go to Zoom, and I'm going to select option 6, Zoom Standard. So this is going to take us back to a nice 10 by 10 grid. There's my first curve, and my second is right there. So again, in this case, my answers are going to be located at the intersection points. So remember, in order to get to that function, we're going to do second, and then we're going to click trace. Option 5 is the one that we want to get to, so again, you can either arrow down to option 5 and press enter, or you could just click 5 on your keypad. So here I'm going to go ahead and look at the curve, or look at the intersection over on the left first. So I'm going to get close to it. I don't have to get super close, but this is definitely close enough. I'm going to hit enter, and then it automatically moves me to the second curve. And you don't have to be exactly on the intersection point. If you are, that's completely fine. So I'm okay with where this cursor is at. I'm not going to move it. I'm just going to hit enter. And again, once you do that, you get a third question that asks you, do you want the calculator to guess where this intersection is? And you went through all the trouble to get there, so I would say, yes, let it guess. So in order to have it guess, we're going to hit enter for a third time. And here's my intersection point. So it's going to be negative 1.27178. I'm interested in the x value because that's the variable that I'm solving for. Keep in mind, again, that this is an approximation. This decimal actually goes on forever, but your screen ran out of space, so what it did was it rounded and cut the decimal value that you see here. So maybe keep this written down on a sheet of paper near you. So now we'll go ahead and we'll uncover the other intersection point, and we have to start this process all over again. So we're going to do second, trace, and we're going to select option 5 for intersect. And I'm on the first curve, or in other words, the blue line, and I'm going to get close to that intersection point. Again, you don't have to be right on it like I am here. You could be further back. That's fine. We'll hit enter, and it automatically moves us to the second line or the second curve. I'm pretty close to the intersection as is. I'm okay with that. It looks good. I'm going to press enter. Now it's asking me, do you want me to guess where this intersection point is? And you're like, yes, please. So we're going to hit enter again. Here's my intersection. So it's going to be at 0.471778. So again, I've mentioned that these are approximations. The solutions that you had uncovered in the previous video were exact solutions. So I want to take a moment to discuss that before we look at the other approach. So I'm going to go back to the home screen. I'm going to clear all of this out. And I'm going to revisit the solutions that we had come up with. So one of our solutions was negative 2 plus the square root of 19. And all of that, let me actually delete that out, and I want to arrow out so that I'm out from underneath the radical, and now I'll close my parenthesis. This entire addition that you see here was being divided by 5. That was one of our answers. When we click enter, we get one of our solutions of 0.47177977. we get a few more decimal places here. Notice on the previous screen, it stopped at the 1, 2, 3, 4, 5, 6, 7th decimal place. There was an 8 here, so they rounded. They looked and they said, oh, there's an 8 next to it, so I'm going to round this 7 up to an 8. The other one that we had was -2 minus the square root of 19, all divided by 5. If you don't want to retype everything, what you can do, depending on the model of your calculator, we can click our arrow key, and we can actually highlight what we had typed in previously. Once you've highlighted it, hit enter, and it calls everything down, so then you can just make slight modifications to it. I'm going to move my cursor over to where that addition sign is, and I'm going to make it a minus sign. This was the other answer that we had uncovered. If I press enter, look, I get my -1.2717797789. Again, when we were looking at this previously, it stopped here at the 5th decimal place, but there was an 8 here. So it had rounded to this place. It looked over and said there's a 9 next to it. I should round this up if I'm going to cut my decimal short. So our second method is going to be known as the zero method. You will use the zero method when you have all of your terms moved to one side of the equation so that it is equal to 0. So again, in this case, I'm going to use the same problem that we had previously. So before we had 5x squared plus 4x is equal to +3. So in order to get everything to one side of the equation, I would have to subtract 3 from both sides, and this would be the result. So now I'm going to head over to my y equals screen, and I still have all of this info. So I'm going to go ahead and tack on that -3 here. And since everything is to one side of the equation, I'm going to clear this line. I'm going to go to my graph, and here's my parabola. So when we are working with a problem like this, when we have all of our terms to one side of the equation, our solutions are going to be at the x-intercepts, or where your parabola is crossing the x-axis. So these, again, are going to be noted as either x-intercepts, your zeros, or your roots. So keep those in mind. All three of them are referring to the same thing. They're synonyms of each other. So in order to find out where they are on the x-axis, because we do not want to eyeball that, we're going to go into second and trace, and we're going to select option 2 for 0. So again, you're going to be asked 3 questions. One of them, I'm going to work on this x-intercept here. I need to get to the left side of this x-intercept. So I don't have to be directly on it. So again, I would actually encourage you to be a little bit more to the left than directly on top of where you think that x-intercept is going to be. So this looks pretty good. Then I need to be on the right side of the x-axis. So again, just want to be far enough away so that I can clearly see that I'm on the right side. I'm going to hit enter again. And essentially that third question is still, do you want me to guess where this x-intercept is? And it's essentially going to pinch the 2 boundaries that you created, and it's going to look for where your curve is crossing the x-axis. So we hit enter, and look, there is our same solution. So we get our -1.27178. So what I want you to be aware of is that you have 2 different approaches that will help you arrive at the same solutions. Let's go ahead and uncover the other x-intercept. So we're going to have to do second, trace, again option 2 for 0, and we want to be on the left side of this x-intercept. So this is pretty close. I'm going to hit enter, and then I want to be on the right side of that x-intercept, and then finally we're going to guess. And lo and behold, we still get that 0.4717798. So I hope that this was helpful. What I would encourage you to do is actually go back and use your calculator to help check your previous work here. Again, keeping in mind that the results that you get from your calculator are going to be approximations where the results that you got by actually doing the algebra were exact solutions.